Record. Okay. Incidentally, this board here, this is to motivate you. This is what people are supposed to learn at the end of third semester of calculus. It's the most involved thing that engineers get. So, you know, look kind of neat. Anyhow, one of my favorite things, but I just put it up there so people in Zoom would have something to look at. We've got a couple of people in Zoom right now. We're doing pretty well. Okay. I've got a couple of comments on the quiz. Now, some people have told me what they think the inverse function is. Looks plausible, but we haven't shown the steps. Okay. Might not hurt you too badly on a quiz, but on a test, you're not getting any credit if you don't show me the steps. Okay? Because you're not doing that in your head. And you got to show me the steps so I know how you're doing the algebra. So don't write down an answer without showing me the steps. Okay? Also, you got to explain how you did the inverse function. Got to have some explanation. And so, well, I think the most common thing I see here is people just turn the graph upside down. That's not an inverse function. You need to be sure you know what an inverse function is. That's not important for the test this week. Well, it kind of is because there are questions about inverse functions on the test, okay? So make sure you know what inverse functions are, and it's going to be very important and what's coming up. So I see all kinds of things for the inverse function, but I think I've only seen, there's one. Somebody wrote a table and then switched the values and plotted those points and then showed me what the curve would be through those points, okay? That's a valid approach. Another valid approach is reflect across the line y equals x. You've certainly seen that in your homework. You've certainly seen that in the My Open Math. Okay. A few people are doing the algebra correctly to invert the function. Other people look like they might have, but they didn't show me the algebra. Okay. But what do you do to do the inverse function? You switch the x and y and then solve for y. Here's your inverse function. Very simple. And why would you switch x and y? Well, what did we originally do for the inverse function? Very first week, we took the table for the basic functions and flipped it around. Okay? Switch the x and the y values. That's all you're doing. So if you got y equals 5x plus 3 over 3x minus 2, you're going to get x equals 5x minus 5y over 3 minus 3y minus 2, whatever it says. Okay, here's a good one. Looks good. The inverse function looks good. That's the best one I've seen. But there are two or three that look pretty good. Here's one where somebody just took it from the first quadrant and put it over in the third quadrant, and it's not what you get when you switch x and y coordinates. Okay? And switch x and y coordinates. That's what your inverse function is. And I've talked about inverse functions because they get real important now that we're getting into exponential logarithmic functions. Now here's one, it shows me a couple of graphs that I switched the points of x and y. Also has a plausible looking inverse function there. And the graph that got switched doesn't look like it's the right one, but still that's how you do it, so that's for something. So, will people just turn the graph upside down? How you do it? That's the reflection. Right? Reflection through the x-axis, that's not the inverse. There's something where the function's not at all what I said it would be, but which may be plausible that we've got an inverse function. So, have to look a little closer at that one. Okay. What I'm saying is, you need to be able to construct an inverse function from the graph, and it's very easy. Switch coordinates, points on the graph. And to get the inverse function, you take the formula for the function and you switch x and y. Okay? That's all there is to it. But then you solve for y, and well, that's more to it, and the algebra can be kind of tricky. The algebra is a little challenge. Okay? So, just to make all that clear, as clear as I can. There's a parabola that goes from the point here up to the vertical. I can estimate the coordinates of points there. Let's say this point is 2, 2. And this point, well, that's 2. That looks like it's maybe 7. That's 2. That looks like it's maybe 12. Okay, on the inverse function, we have the point 2, 2. And let's switch that 2. Okay, so if this is 3, and this is 2, then 3, 2 would be like that. And 7, 12 will give you 12, 7. Well, 12 will maybe be here. And if this is 12, 7 is about here. So here would be 12, 7. Then, really, I don't only need one more point. Let's just take the point here and estimate that. Now, if this is 2, that's maybe 4. And if this is 12, that's maybe 8. And that's not a good estimate. I was trying to make a real good estimate. I thought about with slightly different numbers. If you got 4, 8 up here, then you're going to have 8, 4 down here. You know, there's 12, there's 8, there's 3, there's 4. So you got something like this. Now your graph looks like this. There's your inverse function. You just switch x and y, right? Any questions about that? Okay. Now let's say we have we want the inverse function. What's the inverse function? X and y. So we get x equals y minus 3. Y plus 5. And you solve for y. I'm not going to go through all the steps. But you got 2xy plus 5x minus 3. minus x, not y. Okay. Which means then you got 2xy minus y equals negative 3 minus 5x. Which means you have y times 2x minus 1 equals negative 3 minus 5x. So that y equals negative 3 minus 5x over 2x minus 1. So f inverse of x is this. Now we check that. And I'm not sure I saw anybody actually check this. Because it gets a little involved with the algebra, but we need to be able to do. Okay, so yeah, I'm trying to think of it. More room. Visible. The f inverse of x is what? Well, you plug f inverse of x in here. That's f inverse of x minus 3 over 2 times f inverse of x. F inverse of x, of course, there's 3 minus 5x over 2x minus 1. So this is negative 3 minus 5x over 2x minus 1 minus 3 divided by 2. Negative 3 minus 5x over 2x minus 1 minus 1. Put this over common denominator, you multiply the negative 3 by 2x minus 1 over 2x minus 1, and then you add numerators. And you're going to get negative 6x, negative 11x. And I might screw this up, so it might not work out. But you got to get used to that because you're going to screw it up sometimes and it won't work out. Then you got to fix it. Okay. Plus 1. 2x minus 1. The denominator here. Well, it's going to be negative 5. 2 times negative 5x is negative 10x. You're going to get 2x minus 1 over 2x minus 1. Subtract it. You have negative 10x minus 2x, negative 12x over 2x minus 1. And that's not going to exactly work out. You got negative 6. This is up to 4. Hey, I need to subtract these. What it is. This equals, after some steps that I've gone over in some detail, one I worked in class last time, and others that I've worked earlier in the semester. Just come up negative 11x plus 1. And negative 2. So, negative 11x plus 1 over negative 5 minus 12x. Clearly, this is not equal to x. Okay. If this is correct, then what I get here should equal x. So either I didn't get the right inverse, I messed up the algebra there, remember I did it kind of fast. I messed up the algebra at any point. Or maybe I messed up the algebra here. Or maybe I didn't substitute right in the first place. And plenty of things. So I've got to go back and check my algebra, right? And I'm not going to do that. But now we're coming up on exponential functions.